In-flight refueling for optimum range was given even greater priority, as there had been unfounded criticism of the early plane's results at low level. A major change was implemented for crew survival by deleting the crew ejection module, which had never been perfected, in favor of conventional ejection seats, quite suitable for the slower flying version. With revised specifications from Rockwell and the pressing need to solve the B-52 replacement problem, the Reagan administration announced in October of 1981 the decision to build 100 Rockwell bombers to be called the B-1B. The 4 earlier prototypes, which had done so much valuable work to prove the basic and later the modified concepts, would continue in the test program as the B-1A. It is entirely possible that had these 4 original aircraft not been available, the entire B-1B, the born-again bomber project, would never have got underway. The B-1B was to have many new features, including a modified and vastly improved bomb bay. These cavernous areas can now be adjusted to accommodate different weapons loads and fuel requirements. Clearly, given the success the cruise missile had enjoyed, it would also have to be accommodated. Because the B-1B would be the B-52's replacement, the new aircraft would have to accommodate conventional and atomic devices in a variety of sizes and configurations to fulfill a range of operations. Given this need for flexibility and the far-reaching scope of the B-1 project, it's hard to imagine that serious consideration was not so long ago given to using transports like the C-5 to carry cruise missiles, and that this combination was supposed to replace the classic B-52. As the B-1A continued to prove the new performance specifications, work on the B-1Bs was well underway at Palmdale. The total cost of 100 B-1Bs was to be $20 billion, or over $200 million a plane. But with the lesson learned from the disruption of the earlier program, at least the B model was certain of completion, and this meant, in the long term, the best value for the money. Much of the B-1B's cost goes to provide its sophisticated avionics equipment. Fixed antennas and radar dishes literally project from every angle of the fuselage, all gathering information for its computers to analyze. From this data, the crew will make decisions that may well resolve the outcome of a mission with historic importance, and the fate of the aircraft and those that fly it could equally be at stake. All things considered, perhaps the Rockwell swing-wing bomber is not so expensive after all. Many types of skills and technology are employed as the tens of thousands of parts come together, and the giant technological jigsaw puzzle that is the making of a modern bomber starts to take shape. By the middle of 1983, the first B-1B production model was ready to make its public debut, looking so very much like its predecessor. The new planes are hard to distinguish from those which first appeared almost a decade earlier. Modified air intakes and a small window for the radar operators are subtle but effective clues for the untrained eye. However, the performance variations are not subtle. The B-1B, flying with half the speed potential of the A model, uses 21st century materials to become almost invisible to enemy fighters and missiles, and therefore is far more likely to complete its mission. And all the time it's on its deadly journey, it's providing tacticians with the flexible option of a last-minute recall, a role only the manned bomber can perform, but a role that was often understated in the past.